Okay. So we have to complete the last topic of atomic structure, which is isotopes. And after isotopes, we will do the past paper. So when we talk about isotopes, isotopes are basically the atoms which belongs to same element, but we call them isotopes because they have a difference in the subatomic particles. For example, isotopes are the one which have a equal number of protons in them, but they have a neutrons different in them. If there are two atoms which have a different neutrons and same number of protons, then they are considered as isotopes. And one more thing, if you recall that we have studied nucleons, and what are nucleons? Nucleons are basically the number of, that is the sum of the protons and neutrons in an atom. So if neutron changes, then obviously the value, the sum of the nucleon number also get changed. So we can define isotope as atoms with the same number of protons, but they have a different number of neutrons, or they have a different nucleon number. Is this understandable?
Yes, sir.
Okay. Today is 18th of September, right? 19th. Okay. Then,
Yes, sir.
okay. So here I have put some isotopes of most familiar atoms, which are hydrogen, carbon, and chlorine. So see, this is a one isotope of hydrogen, this is the other isotope of hydrogen, this is the third isotope of hydrogen. If you see, the lower number written over here is same for all three of them, which means this is their which number?
Proton number.
Proton number, atomic number, not atomic mass. Okay, and the above number is the nucleon number, which is basically the sum of protons and neutrons.
Proton and neutron.
Here, these three atoms have a same number of neutron or protons, or their atomic number is same, but their nucleon number or mass number is different. Okay, in the similar manner, these two are the isotopes of carbon, where if you see, both of them have a equal number of protons, but different number of nucleons, which is sum of protons and neutrons. Again, we have a chlorine. in both the atoms there are equal number of protons but different number of nucleons. So if I have to note down all of these, so for hydrogen, what are the protons?
1.
1. There is so much distortion in the background. There is so much noise. So all of these three hydrogen, the number of protons are 1. For carbon, 6. For chlorine, 17. How many electrons are there in hydrogen?
1.
1. Remember, if there is a no charge on an atom, see there is no charge. So the number of electrons and the number of protons are same. So there is going to be 1, 1, 1 for all three hydrogens, 6, 6 for both carbon, and for chlorine it is going to be 17. Now next we have neutrons. Manahil, can you tell me how we will find the number of neutrons? Just check it. Do you know? Yes, whenever we have to find the nucleons, neutrons, we subtract protons from nucleon. And remember, whenever the two values are given with an atom, the smaller value is proton and the larger value is nucleon. Okay, so it means here the number of nucleon is going to be 1 because in this case both the values are 1. Here the number of nucleons are 2. The number of nucleons are going to be 3. For carbon, 12. For another carbon, it's 13. For first isotope of chlorine, it's 35. And for second isotope of chlorine, it's 37. Right? Okay. Now, when we talk about neutrons, as we see that we have to subtract protons from nucleons. So protons, neutrons are the bigger value. So here it is going to be 1 minus 1, which means 0. Here it is going to be 2 minus 1, gives me 1. 3 minus 1, 2. And here 12 minus 6, 6. 13 minus 6, 7. 35 minus 17, I will get 18. And 37 minus 17, 20. Is this understandable? That's how we will figure out protons, electrons, neutrons, and neutrons. And remember, the nucleon number is basically the mass of that specific isotope or that specific atom. So for in this case, for this hydrogen atom, its relative mass is going to be 1 only. For this isotope of hydrogen, its relative mass is going to be 2 only. In the same way, for this atom of chlorine, its isotopic or relative mass is going to be 35. And for this isotope or this atom of chlorine, the relative mass or the isotopic mass would be 37. Is this understandable? Okay, do it quickly. Okay. Done? Yes. Yes, Manahir? Yes, Khatija?
Yes, sir, done.
Okay. So, when we talk about these isotopes, so when we discuss their chemical properties, the chemical properties of these isotopes are going to be same, and it is because they have a same number of electrons and their electronic configuration are same. See here, for all the isotopes of hydrogen, there is only one electron, right? For both the isotopes of carbon, there are 6 electrons, and for both the isotopes of chlorine, there are 17 electrons. So there is no difference in the number of electrons for the isotopes of an element. It means their chemical properties are going to be considered as same. Okay. Okay, note this down. Done. Okay. When we talk
Yes.
about their chemical physical properties, if you see, I have told you that the nucleon is basically the mass of isotopes. So what about their mass? These are all
Different.
three are isotopes of hydrogen and their mass are different, right? These three are the isotopes of hydrogen and their mass are different. As I have told you that nucleon number is considered as their mass as well, their relative mass. So mass is a physical property. So we can see that their masses are different. It means the rest of the physical properties also differ from each other due to the difference in their masses, like their densities are going to be different. Okay. And it is because they have a different nucleon number. And if we know the relative mass of each isotope, like if we see that chlorine have two isotopes, one is chlorine 35 and the other one is chlorine 37. So their masses, their relative masses are 35 and 37. And if we further know that chlorine 35 is 75% abundant and chlorine 37 is 25% abundant, so we know their mass and percentage abundance as well. So if we know these two information, then it will be very helpful to determining the relative atomic mass. So what is basically the relative atomic mass? It is the average mass of all the isotopes of an element. Okay. and I will show you that how we will calculate this. First complete this. Done. Okay, I'm telling you. See, we know there are two isotopes of chlorine. One have a nucleon number or the isotopic mass of 35, and the other isotope is chlorine 37, right? So whenever we look into the sample of chlorine, in that sample, it doesn't mean if there are two isotopes, they are going to uh, exist as a equally, that they have an equal percentage. Okay, so basically when we look into it, and so we will found that the chlorine 35 is 75% abundant in any sample of a chlorine, and chlorine 37 is 25% abundant in any sample of the chlorine. Is this understandable? So it doesn't matter if there are two isotopes, though, so they are going to be equally abundant. It doesn't mean that if there are two isotopes for chlorine, so it doesn't mean that one is still 50% abundant and the other one is also 50% abundant. It is not necessary. Their abundance differ from each other. So for chlorine, these two isotopes, one is basically 75% abundant, the other one is 25% abundant. Is this clear?
Sir, but how you got to know that one is 75% and another is 25%?
Yeah, there are experimental ways by which we can able to figure it out. And for your O levels, you don't need to know about those methods, that how we do it. If there is some sort of question regarding this, so examiner will provide you the percentage abundance of each isotope. Is this clear?
Okay, sir.
Yes,
Yes,
Katika?
yes, clear.
Okay, so this is the expression that we use to find the relative atomic mass of an element. That sign, what does this sign represents? It means sum. Okay, so for example, if we look at a chlorine, how many isotopes are there? Two. We know their abundances, as I have discussed. So we just put these values in the formula. So the first isotope, the mass of the first isotope is 35. Its abundance is 75%. So we multiply these two. Then the second isotope is 30, have a mass of 37. It is 25% abundant. We multiply these two and then we add them. And as we are taking the percentages, so if we are talk about sample, so sample as a whole have 100%. So we divide it by 100, and then we get this relative atomic mass. If you see in the periodic table, let me show you. In periodic table, you are not provided with the nucleon number. Nucleon number is the mass of an isotope. Instead, examiner provide you, see the key over here, relative atomic mass. So see, for chlorine, you are getting 35.5. Its relative atomic mass is 35.5. And if you use the calculator, you can find its value is 35.5. Okay. There is another way of calculating the relative isotopic mass. If instead of these percentages, we got the ratio. For example, one isotope is 75% and the other isotope is 25%. So if I simplify it, what ratio I will get? 3:1. 25 times 1 is 25 and 25 times 3 is 75. So if we got the ratio, so instead of percentages, we use the ratio in the same formula. Okay. And when we use the ratio, then in the denominator, instead of 100, we put the sum of those ratios. So see, the ratio is 3:1 and their sum is going to be 4. So we put 4 over here. If you see over here, it is 75 and 25. If you add these two, what you will get? That's why we put 100 over here. Because whenever we talk about percentage, whenever we take a sample and consider it percentage, so the whole sample will considered as 100%. And when we took the ratios, so we will, instead of 100, we will use the sum of the ratio. Is this clear? Yes, Khatija?
Yes, sir. Okay.
Tanya? Okay. We'll quickly. Khatija, are you done?
Yes, sir.
Yeah. Okay. So what does these charges means? We did it in the last class. Manahal, can you recall? Sorry? Yeah, if it have a two positive charge, then what does this tell me? Check in your notes and then tell me. Yes, Khatija, can you tell me?
They are showing that they are ions.
Okay, they are ions, that's fine if they are charged. But what does this if there is a charge of two positive, then what we can conclude from this?
It lose its two electrons.
It have a two electrons which are lost, so it have a two electrons lesser than the protons. So how many protons this SR have? Yes,
38.
38. Yes, because the smaller value is 38, which means there are 38 protons. Then how many electrons it would have?
36.
Less. So it means 36. Understood? Okay. If there is a negative charge, then what it indicates? It gained electrons. So if it's have a 3 negative charge, it means that phosphorus have a 3 more electrons than protons. And how many protons phosphorus have? Protons. 15, right? So if there are 15 protons, then how many electrons it would have? 18, because it's a 3 negative charge. But if it's like this, then how many protons it have? And how many electrons it has? 15. Because there is a no charge, so it means the number of electrons are going to be equal to the number of protons. But if it have a negative charge, so the value of the negative charge tell me how many more electrons it have than the protons. And if there is a positive charge, then it will tell me the value of the charge will tell me how many more electrons, how many less electrons it have than protons. So in manganese, Mn over here, how many protons? Yes. Yes, Manahil. How many protons this one have? 25. And how many electrons this one have? 7 lesser than the protons. So I would subtract 7 from 25. I will get the number of protons. Oh, sorry, number of electrons. Is this clear?
Yes.
Yes, Khatija?
Yes, sir.
Okay. So now for this you have to do it now. It's your task. You got the values, you have to note down their protons, electrons, neutrons, and neutrons. Sorry? Okay, cursor, sure. Did you understand something?
Yes.
I hope. For electrons, very good. What does plus one charge means?
It's uses this.
One electron. So why the it doesn't mean it loses, it means that it lost its one electron. Yes, Khadija, how much you have done?
Sir, I have done completed.
Okay. This one I done. Okay. You forgot. You have to subtract protons from nucleons. So first write nucleons, the bigger value is nucleons. Yeah, sure. But put the nucleons first. The bigger value is the nucleons, so just put it. Okay. Good, Khatija. Now you guys can check. Okay. Then, okay, check it from here. Okay. Okay. You guys have to tell me the answers. In the first question, what they are asking, this question is about some of the oxides of the elements in period 3. State the electronic configuration of the negative ion in sodium oxide. So, the negative ion is oxide, and as we have discussed that ID, from the name we got its negative ion as ID is written instead of oxygen. So whenever the element, the last part of the name of the element is replaced by ID or AT or IT, then it indicates that it becomes a negatively charged ion. Is this clear? How we got to know that which is negative ion? The name of the negative ion have either ID or IT or AT in its suffix. Okay, is this clear? So we just did over here in the question that you have attempted. What is the charge on oxygen? Just check the last task you guys did. Check what is the charge on oxygen in this task. There is an oxygen element.
2 minus.
2 minus, right? And the number of protons are 8. So if it's 2 minus and it have 8 protons, then how many electrons it have
10.
10 electrons. So if there are 10 electrons, then how we will write its electronic configuration? 2 in the first shell and 8 in the second shell. So all the electrons are substituted and distributed in the shells. The first shell have 2 electrons, then in the second shell we will put 8 electrons. After putting 8 electrons in the second shell, we will put the next 8 electrons in the third shell, and then the 2 electrons in the fourth shell. That's it. That is for O levels. Is this clear? Yes, Khatija?
Yes.
Okay. Okay. Now, who is going to tell me quickly the number of electrons and number of neutrons?
Electrons are 18
Very good.
and neutrons are 24.
Neutrons are 24. 44 minus 20, 24, right?
Yes.
Good. What is the electronic configuration of chlorine atom? So they didn't tell you anything over here. So you have to look into the periodic table. Yes, so how many protons in chlorine atom have?
17.
17. The smaller value is the proton. And if you have any confusion while looking at the periodic table, you just look at the key over here. That is always provided with the O levels periodic table. So see, this is atomic number which is equivalent to number of protons, and this is relative atomic mass. So how many protons are there in chlorine? 17. So they are talking about chlorine atom, right? So do chlorine atom have any charge? No.
Yes.
So it means how many electrons it have? Yes, Sania. How many electrons it have? Why? How then it be an atom? If there is no charge, then the protons and electrons are same. So if there are 17 protons in it, then it means the number of electrons are also be 17 over here. Is this clear? Okay. So can you tell me how these 17 electrons are going to be distributed? How we will write its electronic configuration? In the first shell, 2 electrons. No. In the second shell, what is the space for the second shell? 8. So 8 electrons get filled in the second shell. How many electrons are filled? 10. How many are left? 7. So third shell also have a space for 8 electrons. So but we are left with 7 electrons. So we will have to put 7 over here. Is this clear? Yes, Khatija?
Yes, sir.
Okay. Now, how many electrons this ion have?
80,
80. Two
yes, 80.
positive charges there, which means there are 2 electrons less than the protons. And how many protons it has? 82. So if 2 positive charge indicating 2 electrons less, very good, Khatija. So it is going to be 80. Okay. How many neutrons? 135.
125.
Yeah, 125. That is correct. 7 minus 2 gives you 5, and 10 minus 8 gives you 2, and then 1. So 125 neutrons. Is this clear? Okay, let's try this. For atomic structure, we will get these kind of questions only. Yes. Okay. Choose from the particles shown to answer the question. It means we have to pick the answer from these particles they are provided over here. Okay. Each particle can be used once, more than once, or not at all. Which particle has only 20 protons in its nucleus?
Calcium.
Calcium, right? We got a 20 written over here as the lower value. So we have to write this particle as it was written over there. Is this clear? Which particle has a nucleon number of 35?
Chlorine.
Chlorine, there is only one which is in the first column, the second one, right? Which have a nucleon number of 35. So chlorine 35 and 17. Which particle has an electronic configuration of 288? So see, how many electrons? 18. So which one have going to have 18 electrons? Which one? Which chlorine? There are 3.
37 are nucleons and 17 is proton.
So these are also 2.
Yeah, but it has a
Negative charge. See, it means there are 17 protons and minus 1 charge indicating that one more proton, one more electron than the proton. So this one is going to have a 18 electrons. Is this clear? Yes, Khatija?
Yes, yes, clear.
Okay. So chlorine 17, 37 and minus 1. Which particle is an atom with only 10 neutrons? How we will find neutrons?
Nucleon minus proton.
Nucleon minus protons. So for the one which have 10 neutrons and which must be an atom. So what will be the answer?
There is chlorine, there is 37 and 17.
We got 20. 37.
And E.
So here, if you subtract 20 minus 10, you will get 10 neutrons. And here, 18 minus 8, you will get 10 neutrons, right? But the difference is this one is an atom and this one is an ion because it have a two negative charge. So these kind of the mistakes that a student usually do, they in a quick or in a hurry, they find 10 neutrons. So they will just write this one as well, but they overlook that it's an ion, not an atom. Atoms are the one which do not have any charge. Okay. So it is going to be this one. Okay. Which particle is an atom of a transition element? Okay. How we will do this? Can any one of you what are transition element? Yes, Manahal. Yes, Khatija. Basically, if you see the periodic table, you will find there are group numbers on the top. But if you see this region, there is no group number. So the elements which are present in this region between group 2 and group 3 are considered as transition element. Is this understandable? So here, if you see this is Cu, which is copper. Now, there they have given you copper. So it means copper is the transition element. 29 and 64. Is this clear?
Yes.
Okay. So here you just need to, instead of writing the electronic configuration in the lower, you have to just put the electrons in each atom by putting the dots or by putting the crosses. Okay.
Yes.
Here you have to find the number of electrons, protons, and neutrons. So how many protons are there, Sania? How many electrons? 14. If there is no charge, then protons and electrons are equal. And how many neutrons? 16. Yes, is this understandable? So here you have to do again the same thing. So these are kind of questions. Okay. Now, okay, I think we have to do this one. This one is the interesting one. Okay. But we will do this in our next class. Okay.
Okay.
Because it's a long question, it will take a little time. So we will ending the class here and we will continue this in our next class. Okay? Okay.
Yes, sir.
So take care everyone. Allah Hafiz.
Allah Hafiz.